Okay, last class. So photogrammetry, aerial photogrammetry. So we can call it as vertical photogrammetry also. See, so this this is aeroplane, flight, flight. So flight capturing the image. So in the direction it's called swath distance, a photogrammetry. So it is called as it is also a swath distance along the flight line. If you see a flight capturing certain image, certain part of the image, certain part of the ground, so it will have certain angle theta x. So that's it now. So we can call it as instantaneous field of view, IOV x. So theta x angle divided by number of pixels. Number of pixels we already discussed. So 16 megapixel, 20 megapixel, that means how much pixels, how much megapixels. Okay, so and also in same y direction also it's theta y by ny. Don't need, these are the words will come in advanced photogrammetry. Our class, our syllabus, these terms won't come again. Okay, these are all just idea. Okay, and also ground sampling distance, these are also word will come, no need to discuss. See, and also I shown aerial photographs, vertical, tilted, oblique. So vertical exact, see, optical axis. Optical means what is optical? It is see, it is a focal distance. It is a focal distance. It's a focal distance. Okay, focal distance. We can call it as this is a positive image. We already discussed what is negative image, what is positive image. Negative is there, but there is no positive image. But our calculations we taken as a positive. Say focal distance, we can do calculations based on its positive image, because exactly it will give the image. But in this negative image everything is upside down. So okay, that's why we can take it as a positive image, but there is no image at all. There is no place, there is no nothing is there. Okay, so if it is optical means when we use sunlight or visible light, we call it as optical lenses. You already know it, optical lenses. This optical axis. Okay, we can take this as a photograph. This is a photograph. If you see tilt means just a small tilt. We are last class we said discussed it. We don't want tilt, but in the wind pressure or aeroplane moving, certain camera small, exactly we can't place it exactly vertical. So that's why very small tilt, less than 3 degrees, less than 3 degrees it will happen. We call it as a tilt photograph. Tilt, this is the image, we'll get it. This is the image, you will get it. The less than 3 degrees we call tilt. We don't want tilt images, we don't want, or we don't, unintentional, it is unintentional, less than 3 degrees. So general real purpose, every photograph is tilted, not exactly vertical photograph, we didn't get it. Every photograph. So in RCC also, in structural analysis also, we call it as exactly axial load. Axial load, so there is no chance of getting axial load. If you see, this is a beam. If you applied exact load at center of gravity, it is called axial force. But in real chances there is no chance of getting axial load, because there is a chance of just eccentricity, small eccentricity will happen. So maybe small, very small chances are there, very small, 5 mm, 10 mm, 20 mm chance is there. That's like is very small tilt will happen. Optical axis is just tilting 3 degrees, less than 3 degrees. And oblique image, oblique is we intentionally we will tilt the images, it's called oblique. So greater than 3 degrees it's called oblique images. Okay, so see this, and you can see directly this from pictorial representation. This is optical lens, this is okay. This is low oblique, high oblique. There is no discussion of tilt images. We intentionally put a tilt, it is called oblique. We intentionally put, okay, it's a low oblique, high oblique. So why we need oblique image? We get more details, but the information, see, we'll get more information, but we get very small details. We already discussed previous classes what is, okay. So we already discussed intentional. So where it is, previous class we discussed na, where it is something somewhere. If we get more details, more information, but we will get small details, okay. So if you put an oblique image, we will get more number of so details are, so number of information will cover, but the details are we can get very little, okay. So that's it. See, in aeroplane how can get, so see this picture. So see this picture, it is a vertical photograph, it is a oblique, low oblique, it is a high, so high oblique images, okay. See, we will get more information, that's it. So later I will see one extra words, extra words. See, this is a positive image plane, this is a positive image plane, this is a negative image plane. See, reality there is no positive image plane, just we took the exactly focal length. See, focal length, this is also focal length, this is also focal length. So if tilt is happening, the exactly optical axis is not matching with the center point of the photographs, center point of the photographs. See, this is a center point, see, this is a plane, this is a image, so negative plane, negative image. So one by one, so it is a center point, it is a fiducial marks, so fiducial marks at the edges. So why it is fiducial marks required? So fiducial marks are required for assembling of the photos, assembling of the photos. So okay, we will take so many photos now, we have to assemble the photos. If your fiducial marks is there, we can assemble, we can just exactly getting which photograph is besides the another photograph, exactly matching this photographs. That's why we require these fiducial marks, okay. So that's one thing. And also you know it, this is a flight direction, so negative image plane, positive image plane, so okay, x-axis, y-axis, that's it. And next thing is said is exactly our, so I said no, exactly our optical axis is not matching with the center to center, because small tilt will happen, small tilt. So that's why it, see, this is the image, this is the point, see, small tilt will happen, this is the coinciding points, so this is called principal point, pp point, okay. So what is, if exactly coinciding line is what, it is called a nadir point or nadir line, gravity line, you can call it as a gravity line. So gravity line, see, this exactly coinciding, this is called nadir point, this is nadir point, not a principal point. Principal point is just small variation will have 3 degrees na, 3 degrees will come, okay. That's we discussed last class. So now what we discussed, negative plane, positive plane, fiducial marks, nadir point, principal point, nadir axis, optical axis. So now finally we want to go to scale, scale of the photograph. If we taken the, if we taken, if we in the ground, it may be the distance of this thing, in a photograph it is the distance. So if in ground, maybe it is the distance something, this is the distance of x and y axis. In photograph same will come like this. So how much scale will reduce, how much scale the reduce, or how the scale for the ground distance to photographic distance, how the scale is different, how, that's what is the scale, how, what are the factors influence the scale, okay. So that is the next topic, scale of the vertical photograph. And we taken this picture, okay, we taken this picture. So before that I want to show one photograph, because exactly see, okay. So once again I will delete everything. It automatically saved, so I can't delete everything. nothing. Okay, okay, no problem. It automatically saved. Okay, no problem. We will again discuss through a blue line. Okay, see what is a photograph. So this is a ground, this is a ground, these are the swath distances. Swath distance, if flight is there, that is the swath distance along the flight line. So this one and this one another direction. Okay, so this is the photograph captured. So these are the undulating ground. Okay, so see, this is a negative image plane. Negative image plane. Sir, understood? This is a negative image plane. Negative image. So exactly this is a principal point. So we will discuss only the exact vertical photograph, not a tilted photograph. Tilted photographs required so many iterations, something is there, so no need required. If you have time, just see it, is just listen, that's it. Okay, we will discuss exactly ideal things, not in a real things. Okay, ideal things. So this is a positive image. So see, this is a positive plane or positive image plane. So there is no plane at all. We will take that plane because of the consideration of the problems. So exactly the picture will come, picture will get at the positive plane. Okay, see, so this is, see, exactly every point. So now you can observe it. Now you can observe. So everything is in negative plane is exactly upside down. So how it is, see, this line will, see where it is, we will get it somewhere here. So now we can see, you can observe it, this line, see, you can get it. So on green line also you will get it, you will see the green line. Okay, everything is upside down. But why it is positive plane is, exactly we will see the image on the positive plane is exactly what looks like in the ground. There is no upside down, that's why we require a positive plane. This is the positive plane, na? This is a positive plane. Okay, so now if you consider, I considered some other point. See, some point is there, some point. Okay, some point is there. See one point. So exactly where it is happening. So where it is, maybe this point. See, so in the image it will come like this. Okay, we will take, but ground, if we take ground, we will consider this point, it will come so exactly opposite. So okay, so see, this point is come here, and if you see, this is x, this is y. You can take it, x and y is take is our purpose. Okay, so we will come, if you see, this is a x. If you find out the coordinates of this point x naught and y naught on the image, if you know, this is a ground coordinates x naught and y naught dash dash. So if you know the coordinates of on the photograph, coordinates of the photograph, and if you know the another point coordinates, another point somewhere here, another point coordinates something x1 y1, you will get the distance. Can you get the distance? So can you get the c in this picture also? If you see, this is some other point, some other point. If you want to find out the distance between the two objects on the real ground, so you can get that distance from the directly from photograph. So how can, if you know the exact coordinates of that point on the image, so exact coordinates of the image, exact coordinates of that object on the image, how can you get? You have to get it by the scale. See, I once again said, if it's the ground is there, in ground somewhere is the point here, somewhere is the point. Okay, so what is the distance? This distance we don't know, but we will get from the distance by image. So you will get, it will come like this on the plane. So by the image you have to, you have image. In the image you can calculate, you can just measure by your scale, just scale you can measure. But if you know this is a 5 centimeters, if it is a 5 centimeters, so what is the exact distance on the ground? That is represent a scale, that is represent a scale. So if you know the scale, so 5 centimeters multiply with that scale, you will get exactly how much distance on the ground from the axis, from the axis. So another axis is this is, you will get the another axis, so same another axis. So you will get the x and y axis and multiply with the scale, you will get the coordinates on the real ground. If you know the coordinates on the scale image, how can you get the coordinates on the image? Just by measuring scale. So you multiply that coordinates multiply with the scale, you will get the exact coordinates on the ground. If you know the two coordinates, 2 points coordinates, you will get the distance of between those 2 points easily, because a linear algebra. Okay, so that's it. See this negative plane, positive plane. Okay, everything everything you got an idea. So what is the focal length? This is also focal length. Once again, this is also focal length. So this is also focal length. There is no image at the positive image, we will take it by consideration of doing the problems. Okay, so camera assembly, negative plane, focal plane, this is a positive plane, this is optical axis. That's it. This is the ground. So now we will take it. Now we will take just one point from one axis. Okay, that's it. Now we will take it. See how can you measure the scale. See, this is a O. So that is a focal point, you can call it as focal point. Later it will see, you can extend. This is a negative image, this is a negative image. Okay, no need. So for the calculations we require just a positive plane. We just measure, feel it is a positive plane is there somewhere. Exactly distance of focal distance. This is also focal distance. If you take it, this is a negative image, the image is formed on the camera, there is no positive plane, but we will take it as a positive plane for the calculation of the considerations of doing the problems. Okay, that's it. So this is the exposure center or focal point, you can call it as anything. This is optical axis. See it is, are understood? So now observe it. This is a datum, somewhere it is a datum on the ground. It is a k0 point, it's a a0 point. If you take in the photograph of that area, see exactly it will go this form as a photograph, this, but we did just consider the positive plane. So because we take same focal distance now, so exactly this image exactly form in this plane, we can write it, we can. Okay, see, so this distance is height is h from the exposure point. This is a focal length. This is a k, you can call it as this is a k, this is a naught, because this is a capital, that is small. See exactly what is a, yes, scale is what, the photo distance kao divided by actual distance kao caps. That is a scale means, that is a scale means. Sir, how can you get that is scale? How can you get a scale? See, if this is O A naught and K naught, O small a and K naughts are similar triangles. Just a similar triangles, na? These are the just similar triangles. Now we can write S is equal to scale KO naught divided by KO naught. But these are the similar triangles. See, this is K, this is F, this is F. So KO and AO caps, this is a capital H. Are understood? So these are the similar triangles. You can write OK divided by OK naught. Those are the F divided by H. Similar triangles, na? Similar triangles principle, you already know it. So this is a uniform slope. You can convert into the mathematics. It's uniform slope, how much it is increasing. So this is O, this is K, this is K naught, this is small a naught, this is capital A naught. So this is a uniform increasing, uniformly increasing load. Load, not load, but in structural analysis you can call it as uniformly increasing load now. So how much it is increasing, you already know, easily you can calculate it, because it is a constant slope. That is a constant slope, that means similar triangles you can use. So see, OK divided by OK naught, so KAO divided by KAO, that's it, na? So see, F by H. So what is the scale? Scale is S is equal to F by H. That is the scale. Scale is F by H. F by H. See, understood? F by H. So that's it. That is the scale. Photo distance by ground distance. So if you know the photo distance, if you know the photo distance of 5 centimeters, you can get the exact how much distance on the ground. Can you get it? So okay, how much you can multiply with h by small h, capital H by small h, capital H by divided by small f. That's it now. So see, this is a photo distance by ground distance, so you can reciprocal it. So capital H by h, maybe capital H is, maybe it's a, so mostly it's a 200 meters or everything like this, 200 meters, 300 meters, that's enough. Divide by focal distance of maybe 1 meter like this. So it's multiply with 200. So if you multiply with the 200, you will get the exact distance of that point, exact distance of the point from the optical axis on the ground. You will get it now? So that is scale is f by h, or you can call it as a cap h by f. So if you want to increase or if you want to decrease, if you want to calculate the ground distance or if you want to calculate the photo distance for in the distance in the photo, distance in the photo or distance in the ground, so you can directly get it from capital h by f or f by h. Or get it? Very simple. No need to discuss it. Okay, so that's it. That's the one thing. So if you get it 1 point, so my intention is, if you see, this is a 1 point. For a point, that point has a scale. So from the optical axis you will get that distance. If you see, some maybe situations ground is not an uniforming. Ground is maybe, if you see the ground, if you see the ground somewhere has very slow. If it is a datum, it is a very datum. 1 point, one position or one particular point has certain height, certain point has low height. Ground is an undulating ground, it's not a uniformly ground. So most probably 99.999% it's no chance to get a uniform. So we will get, see, 1 point has a slope f by h. It is a scale, that point from optical axis, from the optical axis to that point, we get the scale of f by h. F by h. So okay, f by h. H means what? What is that h? H means, see, what is the h means? H means the distance from the optical or from the focal exposure center to the that point. H na? H. If you see, every point there is no chance, every point there is no chance of maintaining the same height from the optic exposure center. Every point has certain height or decrease. Okay, it's not in a uniform. So if you see, each point has some distance from height, this point has some distance, small height increase. Are understood? So every point has different heights from the exposure center. So if you observe it, so every point has different scales. Are understood? So first point f by h1, so second point some other point f by h2. So every point has different slope, different scales na? Different scales. That's the one thing you have to observe. Second thing is, we have to take in something for absolutely or ideal calculations or ideal words. We have to take in this h is from datum mean sea level. We already know it, datum mean sea level surveying. So if, see, this is a mean sea level, this is a mean sea level. So our position is something, so maybe we are exactly very near to the ocean. We get very small, I think 20 meters, 30 meters above, 200 meters, 300 meters above the mean sea level. Okay, so if it is datum line, if it is a datum line, so our surface is like this. So okay, so like this, so we calculate scales, this datum distances we can call it as a h from the focal point, from the focal point. So we can take this, maybe this point height is, this point is, if it is small h, we everyone knows it. So if you go to the meteorological department or anything, so sir Nuzividu, so Nuzividu is 200 meters above the mean sea level, they will say it. So Himalayas 10,000 meters from the mean sea level, are understood. So Tibet is very 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 high altitude point. So that means what, that is from mean sea level. If so, if you want to take a photographs or thing, if you have to collect the data na, so that collected data they will say it is mean sea level is everything is perfect, everything is no mean sea level, we know it. So from mean sea level how much height is that, how much height is that surface, directly surface, this is h. So if you want to take the capture of this surface photographs, so scale is what, scale is just this na, we calculated, we already see it, this is exactly this height. H means what, see, we take a h is that point, so exactly that point. But if some of the textbooks or some ideal calculations are exactly uniformity over the all calculations, we taken see, we taken this is h is a mean sea level height, mean sea level height from the focal point, from the focal point we can take it as a h, and this h is altitude level, altitude level, altitude level. So if you taken like this, so what is scale, scale is just f by h minus h, that's it na? We just consider, see the proof. No, there is no proof, just very small. Okay, we want, we taken this height, focal point to this objective. So focal point to this objective na, so focal point to this objective we can take this is h minus h, because this h, this point is certain height from the mean sea level. Okay, so we can take it this h. So if you observe it, if you observe it in the surface, in the surface, in the surface, this is surface you can call it as, every point has different heights na? So this point has different, so this point has distance, this point has certain height. So previously we call it as, see we write like this. So you can find out that every point has different scales, f by h1, so st f by h minus h2, you can write like this, that's it na? Every point has different scales. So how can we get the uniformity over the photograph? In a photograph we had so many information, that means so many points we have to look at it. Every point mentions different scales, because every point, not in every point on the exact uniformity, every point has certain height, altitude differences are there, because it is the altitude undulating ground. So every point maintains different scales. We want a uniformity, s h f by h, uniform height, average height. So we will take average. So they, based on that we will get the details, get the details from that photograph, because we don't maintain every point, every point has different scales. We didn't want to do calculations based on that different scales, not in infinite scales, because infinite points are there on the photograph. So we will get the uniform, how can you get the uniform? So based on the ground structure, it is a undulating or moreover most maintain the uniformity. So we will take certain points and we will take an average height, average height of that, average height of that surface. Okay, so that's a one thing. So now I will show these in the photographic pictures, because if I say orally you can't understand. Okay, see now you observe it. First two pictures. Okay, first picture is that, so we will take it as a datum, not a ground. So datum mean sea level you can take, otherwise you can consider one thing is a datum, one thing is a datum, you can consider it. Every time you don't want to consider the datum as a mean sea level, you can take datum as one reference line, one reference. So for the India, one reference. For the other country, they will put one reference line, that is a datum. Mostly mean sea level is taken as a datum. So now you can consider this datum. The point A has certain height HA. So this, సార్ చెప్పండి సార్. నేను క్లాస్లో ఉన్నాను, ఒక 15 minutes తర్వాత చేయండి. 11 తర్వాత నేనే చేస్తాను. So okay, is it okay? Visible? Hello, is it visible? Okay. So see, these are the photographs, you can observe it. It's a datum. This is a HA, this is H minus HA. You can, this H is a datum from the focal point or exposure point. You can call it as exposure point or focal point, anything. So this is H minus HA. So same thing, same proof, no need required. H F minus H minus A, similar triangles. Okay, so no need. This is F by H minus H. So this is height of the object from datum. This is datum distance from exposure point or focal point. So this is a scale. You can take is F by H minus H or H minus F by H. You want to increase or decrease, you want to calculate the object to distance in the photo or in the ground, just it. Okay, that's the one thing. So if you know this one thing, so now you can observe it. So sorry, so now you can observe it. So see, B point is different altitude, A point is different altitude. So if you take an B point, so this has height from HB, it is H minus HB. If A point is H minus HA, so we will get the same. So B and A points are on the photograph. So okay, see, this is a point, this is a B point. We will get it. So we will get it like this. We will get it now. Exactly, we will get it like this. So how can the scale is different? Scale is varying. So every point scale is different. Are understood? See, so this A point has F by H minus A. So if you taken this, height, this distance and this distance, you can't calculate it. So this distance K small b is KB capital B into, so F by H minus small b. You will get like this. Otherwise, if you want K small a, Ka capital A, F by H minus small a. So every point has different scales. Are understood? So get it idea? That's idea. So if it is different points has different scales, so how can you get a uniformity? So how can you get the uniformity? See, it is a data scale at datum or mean sea level. Okay, datum is a reference. Otherwise, scale at one point on terrain, you can get that HP is the height of that point from the datum. There's a HP, height of the point from the datum. So if every point has different scales, how can I get? We'll get average based on the terrain. Based on the terrain, we will take the height of every objective taken into the consideration. We will give one average height. So based on that scale, we will get the information. We will get the details. We will get the details or information from that photograph. That's it, na? So that's it. So that's the one thing, and later it's relief displacement. So very small topic we discussed today, and we will solve one small problems. One very small problems. These are the not problems. These are all very normal. Okay, normal problems. No need to. These are objective questions. These are all objective questions. So take a problem. So the elevations of three different points A, B, C above the datum are respectively 1500 meters, 1200 meters, 1000 meters. If the height above the datum is, if the height means it's a flying height or flight height. If the flying height above the datum is 3000 meters, determine the maximum scale or minimum scale or average scale. Focal length is 150 mm. Okay, so A, B, C, different points on the ground terrain. They have elevations of 1500, 1200, 1000 meters from the datum. Flying height is 3000 meters. Determine the scales, average scales. So see, there is nothing to do. Scale at A is, what's scale at A? F by H minus HA. So that's it, na? It's a 150 mm. It's a 150 mm. Bottom is height. Flying height is from the datum is 3000 meters. 3000. So first point A is 1500. These are the meters. So this is mm and meters. If you taken this is 10 minus 3, you can write it's meters. Okay. What is that scale? That scale is 1 by 10,000 or 1 into 10 power minus 4. That is the picture. That is how much shrunk the distance in the photograph based compared to the real distance. How much shrunk it, or if you reverse it, how much expand, how much elaborated, how much is the real distance from the ground, in the ground. So opposite, na? Exactly. So how that much distance, that much shrunk in the photograph, that much details, that much is compressed in the photograph. You can call it as, or you can express in your ways. Okay, that is the first point. Second point, no need to write again and again. So 150, 10 power minus 3, 3000 minus, second point is 1200. So 1200, this is 1 by 12,000. Third point is same again. It is 1000. 1 by 33, 13333. You will get it. So these are the scales. Now 1, 2, 3. Minimum, maximum, no need. So if this type of different point has different elevation, we need an average. So how we will get the average? The average is just the average of the elevation. We will take average of elevation 1500, 1200, 1100 divided by 3. You will take 1233.33. If you find out the average scale, so 3000 minus 1233.33, you will take this 1 by 11,778. This is the average scale. Based on the average scales, you can analyze the photograph. Okay, that's it. That is the one thing. These are the scales. And next thing is I want to find out the so I want to find out the extra problem. So second problem is the measured photo coordinates of images. The measured photo coordinates of the images A and B of two ground points capital A and capital B are XA is 45.33, YB is 38.41 mm. XB, XA and YA. XB is minus 40.16, YB is minus 45.65 mm. Determine the ground coordinates of A and B and compute the distance between the points A and B, capital A, on ground. So that's it. So if you know the image, see the measured coordinates of image. He said that this is the image, something like, if it is image, he find out the one point. So A point is somewhere here. He said that XA and YA. This is called small a point, XA and YA. And third coordinate negative. Somewhere B point is somewhere here. This is X and this is Y. This is XB and YB. Based on that, if you know the photograph, if you have a photograph, you can directly take by small scale, your roller scale. Get it now? So he said that these are the coordinates of the points of small a and small b on the photograph. So you have to find out the coordinates of the points capital A, capital B on the ground and find out the distance between these 2 points. Distance between these 2 points on the ground, actual distance. You have to find out. Can you find out? Very easily. Why? So see, how can you find out? See this problem. So directly multiply with the scale. If you see, XA is what? In photograph is what? So photograph is 45.333. So in ground, how much is the coordinates? So directly multiply with the scale. Scale is, so we know the ground distance. See, we know the photographic distance. We have to find out the real distance. So we have to invert it, na? So we have to invert it H minus HA by F it. That's it, na? So see, it is, we already discussed. This is if it is XA. We already know this is XA. The ground distance is how we'll get. So that XA is multiply with 1 by scale. That's it, na? That's it. So we know the y distance. Same is also YA. We will invert to the scale. We will get the coordinates of that point on the ground. Get it, na? So get it. So now what is the H? They didn't give the values. Okay, I will give the values. A is 200 meters B is 150 meters above the datum, and also flying height is, okay, flying height H is 1500, focal length F is 152.4 mm. Okay, those are the details. Focal length of the camera axis, optical axis. A and B are 200 meters and 150 meters above the datum, and the flying height is 1500 meters. That's it. Can you calculate? The coordinates? So easy. So find out. H is 1500, HA is height 200 meters, F is 152.4. This is 152.4. So that's it. That's it. What is the coordinate? So this coordinate 386.84 meters on the ground. Okay, that's it. So based on the same YA is what? Plus 38.41. Same thing, same factor. You will get it 327.64 meters. For B, XB is minus 40.16. So H minus HB. So now it is HB is different from 150 meters height. So what is that value? That value is minus 355.75. So YB is minus 45.65. Same scale, 404.38. Scale is different from A point and B point. Observe it. This is A point and this B point. Scale is different for A point and B point. So if you know the coordinates, can you find out the exactly ground? So this is a ground. This is a ground. So one point is something this. Second point is in this. Can you calculate the distance between these 2 points? Can you get it? So what is the distance? Distance is what? XB minus XA whole square, YB minus YA whole square. This is a school level. I think you will get it in 7th class, I think. 7th class, 6th class. If you know the coordinates of 2 points, you will get the distance between those 2 points. Okay? Get it now? So get it. That is the distance. So find out the distance between those 2 points is, this distance between 2 points is 1042.73 meters. That's it. You will get the distance between those A point and B point on the ground. You just took the photograph. Based on that photograph, you can say the distance between any 2 points on the ground. I understood. It's related to surveying. I understood. You just diverted from surveying. Just feel it is a surveying. You have to find out the distance between any 2 points by just taking the photo. If you've taken the photo of the picture from certain height, you can measure the distance between any 2 points. Get it? Get it the point? You will infiltrate into the surveying. Just don't divert from the surveying. Just think like a surveyor. Okay? That's it. That's the one thing. Okay? That's the one thing. So I want to explain some other things, but it's almost 11. Okay.